Hi guys, and welcome back. So in the last video, we took a look at how to create a service controller that routes traffic to pods, and we exposed that service controller on a node port, and then we were able to hit our nodes on that external port and have the service controller forward traffic to the pods. Now, another option that you have for the service controller is to simply create a service on an internal cluster IP address. So if we refer back to our diagram right over here, you can see we've got this cluster internal network right up here. And instead of exposing it through this node port, we can take this service controller and just basically give it an IP address on the cluster network. And the only way that we'll be able to then access that service is from another application that is running internally to the Kubernetes cluster. So let's take a look at how that could work. So for starters, I'm going to go ahead and spin up a service, and I'm going to have that service basically forward over to our Nginx pods here. So we'll be using the same selector. However, the difference in this case is that rather than using the node port service type, we're actually just going to give it the cluster IP type instead, and that will not expose it using the node ports that we had previously used. So instead, what we're going to have to do in order to access this service and kind of test out connectivity to it is to spin up another pod running some kind of interactive application. So we'll bring maybe a terminal pod up here, maybe have something like a PowerShell shell that we can use to kind of ping the service internally. And so that pod will be able to communicate with the cluster internal network. So that's the only way that that service will be exposed in this particular case. All right, so let's head back over to our terminal here. And I'm going to close down my little test VM over here. And what we're going to do is spin up a pod. So we'll do kubectl create pod, or actually we'll do kubectl run, sorry, and we'll do image equals nginx, and we'll expose it on port 80. And of course we need to give it a name as well. So let's call this cluster IP pod. And then we need to create a service controller that's going to forward traffic to this pod, but we also need to give the pod a label. So let's run back to our label command here, and we'll fix our pod name to be cluster IP pod. And then let's call this maybe just type equals cluster IP. And then when we create a service controller, we'll configure it to use this label of type equals cluster IP as its selector so that it can forward traffic to the correct pods. So we'll do a kubectl get service, and I'm just going to kill off this service that we had before just to keep things clean. So I'm going to delete the my Nginx app service. That's the one that was using the node port configuration over here. Of course, I need to prefix that with the resource type. And now we'll just verify that it's gone. And all right, now we can create a new service. So we'll do a kubectl create service. And in this case, instead of using the node port context, we're going to be using the cluster IP context. And then let's take a look at the help for that. And of course, we're going to need to give the service a name. And as far as the input parameters go down here, the only one that we would really be interested in potentially would be the cluster IP here, because this allows you to actually statically specify an IP address if you want to set it to one that you already know. Otherwise, Kubernetes is just going to assign a random IP address from the cluster CIDR block to that particular service. And then, of course, we'll be using the TCP port down here to forward traffic to our pod on the correct port. So I'm going to go ahead and just specify a name for it. Let's call it cluster IP service. And then I'm going to specify the TCP parameter, and we'll say forward traffic from port 80 to port 80. So our service controller will basically be listening on port 80 on its internal cluster IP, and it will forward traffic to our pods, our pod containers on port 80 as well. All right, so we'll create that, and then we also need to edit the selector for it. So we'll do kubectl describe service cluster IP service, because the default selector is probably going to be based on the name. Sure enough, it's just set to app equals cluster IP service. So we need to change that selector label to use the one that we assigned to our pod. And so that's just type equals cluster IP. All right, so let's do kubectl, and we'll do set selector. And then we need to specify the name of the service. So we'll do service / cluster IP service. And then we'll specify our type equals cluster IP label. All right, so now it's been updated, and we'll just do a describe on it to make sure that it has been updated correctly. Sure enough, you can see selector is type equals cluster IP. So that matches our pod label. So if we were to do kubectl describe pod cluster IP, I think, did we call it? What was the name of that? Let's just hit up arrow here a few times. Oh, it's cluster IP pod. And we should see that label applied on it. Sure enough, there it is. All right, so that service controller should be able to route traffic at this point. So what we want to do is basically hit this cluster IP address for the service controller on port 80, and then that service controller is going to forward to the configured endpoints, which are, of course, dynamically selected based on the selector. So one of the things that we'll have to actually do is spin up a pod that is on the cluster network so that it has access to hit this service. So let's run a kubectl run, and then we'll do standard in and tty so that we get an interactive shell. And I'm going to use the image mcr.microsoft.com/PowerShell, just so I have a PowerShell environment to work inside of. And then we'll give this pod a name. So we'll maybe give it a name like pwsh. And this should allow us to attach to that container because we did standard in and tty. When you use those options together, it basically allows you to have an interactive shell on whatever pod you are spinning up. All right, so for some reason, kubectl always does this weird thing where it feeds in a bunch of random text into your shell, but you can just ignore that. So now what I need to do is install a utility. Actually, I don't really need to do that. I think I can just use the invoke web request command here. So let's do PowerShell's invoke web request, and then we'll do the URI parameter here. And our URI is, of course, just going to be HTTP followed by the IP address of the service controller. And of course, it'll be on port 80. And so let's try that out. And sure enough, you can see that we are able to hit this service. Now, if I was to try to hit this service, hit this cluster IP from outside the cluster, then you'll see that we are not able to hit it. So I'm going to go back to the other virtual machine that I spun up earlier. Let me do an SSH session here. And remember that this virtual machine that I spun up is actually sitting side by side with our worker nodes. So it's on the same VPC as the worker nodes, but it's not a member of the cluster like the worker nodes are. So if I was to try to use that same URL and hit it from this virtual machine running Ubuntu Linux, you'll see that we are not able to route traffic because that cluster IP address that the service controller has is sitting on that internal cluster network rather than being exposed on the Amazon VPC. And because we don't have a node port configured, we can't even hit the worker nodes on the outside and then have the worker nodes forward the traffic to the cluster network like what we saw in the previous video. Because we're not using the node port type, we're only exposing the service on the cluster internal network. So that's one other option that you have for exposing your Kubernetes services for services that don't need external access. I hope this has been informative for you, and I'd like to thank you for viewing.